Example 2 is in fact an exam assignment from 2017. We have a final product A. For this final product, we have the product structure tree. You can see the components, different components B, C, and D, and how they are assembled to form the final product. And we also can see the number of units required to do the assemblies. For example, for product A, we need subproducts or subassemblies B and C, and we know that we need two units of product B and 3 units of C in order to be able to produce A. And in a similar way, we can say for B we need 1 unit of C and 1 unit of D. And what we need to do is to fill in this material requirement plan for the different components. For A, from the master production schedule, we have some quantities to be ready in weeks 2, 4, and 5. So we want 100 units to be ready in week 2, and 200 in week 4, and 150 in week 5. Given the production lead time, this 1 week, we need to start the production in week 1 in order to be able to deliver this 100 units in week 2. So in week 1, we need to start the production of 100 units of product A, for which we will need all of the components to be ready at that week, in week 1. And it is the same for the next week. So if I drag it, so I know that in week 3 I need to start producing 200 units of product A, and in week 4 150 units of product A. Now let's go to the next table, which is table for component B. Component B is only used in product A, right? So here for the growth requirement for component B, I will see the numbers that need to be ready in each week for product A. So I want to have 100 units ready in week 1. I need to start the production of 100 units of product A in week 1, so I want all of its components to be ready by that time. Or in other words, I want 2 times 100 units of B to be ready in week 1. Why 2? Because each product A requires 2 units of B. So to be able to start producing 100 units of A in week 1, I want 200 units of B to be ready in week 1. That is why we have 200 here. And it is the same for the next week. So we have 400 for week 3 because we want to start production of 200 units of product A, and so on. There is 200 units already scheduled in week 1, so, and there is no other scheduled receipts in the other weeks 2 to 6. So we can move to the next part, in which we will calculate projected ending inventory. Projected ending inventory, we will use this formula, as you may know. So the projected ending inventory is the difference between inflow and outflow. So ending inventory from the previous month, from plus scheduled receipts plus plus scheduled receipts plus planned receipts, yes, this cell, minus growth requirements. So it will give us the ending inventory. Ending inventory here is 50, which is again intuitive because in week 1 we will receive 200 and we have 50 from the previous week or from the last time period. So in total we have 250 units available and the gross requirement is 200 and the difference is 50, so we will have 50 at the end of the week in our inventory. I am dragging this cell so we'll get the inventory for the next weeks as well. Now I am doing the net requirement calculations. We are using the formula for the net requirement, and it is the max of 0 and gross requirement minus ending inventory from the previous bit minus the scheduled receipt. So here the inflow, the scheduled receipt plus the inventory from the previous month is enough to satisfy gross requirement 100, so net requirement is equal to 0. But if I drag it for the next time period, for the next week, I can see some positive values for the net requirement in week 3 to week 6. Then in week 3, I need to have some planned receipts to satisfy this net requirement. Minimum order quantity is 1, so I can make an order of 350. That would be enough to satisfy the requirements in week 3. And then in week 4 I need another planned receipt of size 300, and then I can see that I have no further net requirements for the other 2 weeks, 5 and 6. So these are my planned receipts for weeks 3 and 4. And I know that the lead time is 1 week, so I need to place an order in week 2, an order of size 350, in order to be able to receive that order in week 3. And it is the same for week 4. Now we can move to the next table, which is for component C. As you can see here in this product structure tree, component C is used for producing product A and also for component for producing component C. So the requirements for C stems from the requirements for A and also the requirements for B. Therefore, to calculate the gross requirements for C, we need to take into account the requirements for both A and B. So here I am saying that each unit of A requires, as you can see here, 3 units of C. So I am multiplying this number by 3 plus what we need for B multiplied by 1, because for B we need just 1 unit of C for each unit of B. And if I drag it, I will get these numbers for the next weeks. What does it mean? For example here, it means that to be able to start the production for product A, I need to have the materials required for 100 units of product A ready in week 1. And for 100 units of A, I need 300 units of C. So I make sure that 300 of C is ready in week 1. But there is nothing here for for B, so we will not take it into. So it will give us 0. We'll take it into account, but it is equal to 0. But then in week, for example, 3, let's see what do we have here. We want to start a production for A, 200s of A in week 3, so we need all of its components to be ready in week 3. So we have a gross requirements of part C equal to 600, 200 multiplied by 3 in week 3 to satisfy, to be able to start a production of product A. We also need to start a production of 300 units of product B in week 3. And for each of these units, I want to have 1 unit of C ready by that time. So 600 plus 300 will give me 900. So I want 900 to be ready in week 3, and it is the same for the next weeks. Now I can move to the next part in which I am calculating projected ending inventory. Projected ending inventory, again I'm using the formula that we can see here, so it is equal to inventory from the previous week plus scheduled receipts plus planned receipts minus the gross requirements, and the same for the next weeks. Then net requirements, which is maximum of 0, and gross requirement minus ending inventory from the previous week minus the scheduled receipts, and is 0 for week 1, and I am just dragging it so I will get these numbers for the next week. Here I can see that I have a net requirement equal to 850 in week 3, and the minimum orders that I can make are of size 500. So here I will make an order of size 850 to satisfy this net requirement. Then in the next week I again have a net requirement equal to 450, but here I cannot make an order of 450, so because the minimum order quantity is 500, so I will make an order of 500, or let's say the planned receipt will be 500 for that week. And by that planned receipt, so I will have no further net requirements for the other 2 weeks. And then these are the planned receipts. I need to calculate the time in which I need to release the orders, and to do so I need to know the lead time, which is 2 weeks in this case. So for 850, the planned receipt in week 3, I need to release the order in week 1, 2 time periods before week 3. So it is 850 in week 1, and it is the same for the next week. We can do the same calculations for the next component, component C, but here we know that C is only used for product for the component B. So for the gross requirements, we will only use the planned order releases for component B, as you can see. And because each component B requires 1 unit of D, so we just take the same number, and we do not need to multiply it by any other value. And the rest of the calculations are just the same. Here, just pay attention to the minimum order quantity, which is 1000. So of course the net requirement is 150, but we need to make an order of 1000 because we cannot do a smaller order.